Hi friends, in this session we are going to discuss about Friss free space equation. Friss free space equation. This Friss free space equation was developed by Professor H.T. Friss. Professor H.T. Friss in Bell Laboratories in the year of 1946. This Friss free space equation is used to calculate the received power by the receiver. So we know that in the communication system we have different two types of antennas, transmitting antenna and receiving antenna. We have already seen that power radiation equation, power average power equation, power density equations, so on, but we didn't calculate any power receiving calculations. In this session, by using this Friss free space equation, we are going to calculate the radio transmission loss as well as how much power received by the receiver. Let us consider an isotropic radiator. We know that this isotropic radiator radiates same power or same radiation to its all the directions. Isotropic radiator. For this isotropic radiator, we know that the average power equation P average equals to P radiation by 4 pi r square. Units are watts per meter square. This is the average power equation, and we know that also the gain equation, the maximum directivity gain or gain is given by GD max D equals to, or GD max equals to maximum power density by P radiation. That implies I am substituting this P average value in this equation. GD max equals to P D max by P radiation by 4 pi r square. So this GD max is nothing but this directivity is at the transmitter. So similarly, so let us giving the equations. This is the equation number 1 and this is the equation number 2. We have the power received equation by relation between the effective aperture and power density maximum power density is given by power received equals to P D max into A. Here we are considering the effective aperture for receiving antenna. For that purpose I am placing the r. So we have that PD max equals to, by this equation 2, PD max equals to GD max T into P radiation by 4 pi r square into AE of r. I am giving the equation number 3. But in general, the directivity, we have an relation between the directivity gain and effective aperture. That implies, we know that GD max equals to 4 pi lambda square into AE. AE for effective aperture, lambda is wavelength, and GD max is maximum directivity gain. Let us consider this GD max for receiving antenna, because we have the formula for in terms of power received equals to PD max into AE. Okay, we have the relation between the power received, nothing but for the receiving antenna calculation of the power receiving, we have the relation between the effective aperture and power receiving. So for that purpose, I am assuming that this is the AE for receiving antenna. So AE for receiving antenna as well as GD max also belongs to receiving antenna. Then AER equals to GD max R into lambda square 4 pi. I am giving a equation number for this one. This is equals to 4. So substituting this AE value in this equation, in this 3 equation, power received equals to GD max of transmitting antenna into P radiation by 4 pi r square into AE for GD max for receiving antenna into lambda square by 4 pi. So here is the equation. By substituting the equation 4 into equation 3, power received equals to GD max of T P radiation by 4 pi r square into GD max R lambda square by 4 pi. P received by P radiation is equals to GD max of T into GD max of R into lambda by 4 pi r whole square. Here is the lambda square and here is the 4 pi, here is the 4 pi, r square, we can get this equation. This equation can be called as fundamental Friss free space equation. This equation can be called as fundamental free space equation. Here lambda by 4 pi r whole square can be called as free space path loss. The path loss be expressed in terms of dBs, 10 log 10 4 pi r by lambda whole square dB. The path loss for P loss. Lambda square by 4 pi r whole square is free space path loss. Let us consider whenever we are radiating some signal from transmitter to receiver, there is no medium in between the transmitting and receiving receiver, transmitter and receiver. It will be uses the free space. Whenever the transmitter radiates to the free space, there may be a obstacle or objects or atoms in the free space. By using that atoms and objects by the free space, some radiation will be lost and some amount of radiation will be received by the receiver. The received by the receiver is nothing but power received by receiver, and some amount of loss, the some amount of loss will be due to the attenuation. The attenuation equation is nothing but attenuation can be calculated by 4 pi r square whole square is nothing but attenuation, and the loss by the free space is nothing but free space path loss is nothing but lambda by 4 pi whole square. This equation and the attenuation also known as LS. P received by P radiation is equals to GD max T into GD max R lambda by 4 pi R whole square is in terms of dBs. We can write 10 log 10 P received by P radiation equals to 10 log 10 of GD max of T into GD max of R into lambda by 4 pi R whole square. This term is also written as 10 log 10 of GD max of T plus 10 log 10 GD max of R plus 10 log 10 lambda by 4 pi R whole square. So here is nothing but GD max in dB. Here is GD max T in dB, GD max R in dB, and 10 log 10 lambda by 4 pi R whole square is nothing but, we know that the attenuation is nothing but 4 pi R by lambda whole square is equals to LS. By changing the numerator to denominator, denominator to numerator, this can be also written as 10 log 10 GD max of T plus 10 log 10 GD max of R minus 10 log 10 4 pi R lambda square is nothing but here GD max of T in terms of dB plus GD max of R in terms of dB minus LS in dB. Here is P received in dB by P radiation in dB. So to obtain the expression for field strength is nothing but the electric field at the receiving antenna by using the Poynting vector. We know that the Poynting vector is P equals to E into H. To obtain the magnitude of the power delivered at the receiver, we can write the E into H equals to E by neta naught. Here E is the electric field and neta naught is nothing but intrinsic impedance. Here P is maximum power density. PD nothing but maximum power density can be expressed as PD max equals to E square by neta naught. By simplifying this equation, E equals to under root neta naught P D max. We know that the intrinsic impedance neta naught equals to 120 pi for the free space. So nothing but 120 pi is nothing but 120 into 22 by 7 is nothing but 377 ohms. Neta naught equals to nothing but E equals to under root. We have solved that equation from the previous equation is nothing but PD max equals to here this equation. We are considering this equation. PD max equals to GD max into nothing but PD max equals to GD max into P radiation by 4 pi r square into we can write the 120 pi or 377 directly. 120 pi. So here pi gets cancelled. 430, nothing but E equals to 30 GD max into P radiation by R square under root. The units are volts per meter. This is the electric field. Electric field for free space. Friss free space. The above equation represents the expression for field strength at the receiving antenna for the wave propagation in free space. Thank you everyone.